This is kind of a big topic, errors. Previously, we've come across errors as part of our examples, and we just we read the thing and we brushed them off a little bit. Now what I want to do is I want us to go into a lot more depth about errors. How to handle them, what to do when they come up in your program, what to do if they might come up in your program. So we're going to call this errors.py. And we're just going to start by doing something we know is going to cause an error, and then we'll talk about what to do about that. So if I say hello plus 5, right? I print out hello plus 5 and I run this. Oh, whoops, running the wrong thing. I go to my errors.py and I run my errors.py. I get back an error because I can't combine these two things. Now let's take a closer look at this error message. Type error. And I'm trying something different in this video. I'm actually trying to zoom in, see if this works or not. But type error says, hey, this is the kind of error it is. It's a type error. Can only concatenate str, not int, to str. So we can only concatenate, we can only combine strings to strings. And it's a type error. Why? Because the type is the wrong type. Now it says trace back, the most recent call, which means this is going to show us if we call a function that calls a class that then results in an error, it's going to go all the way back. But it's a file. It says the file that called it, and it's line number 1. And it says, hey, this is exactly the piece of code that ran last that gave us this error, and then we get this type error. Now, this is helpful because it gives us the kind of error that we're dealing with, and we know what to do about it. We know that we just have to change the type of our 5 to a string, and we'll get an end result, which is great and all. What happens if we don't want our code to fail miserably in the meantime? We don't want our whole program to crash. We just want to try something, and if it doesn't work, we want to keep going. So what we do is we do something called a try except loop, or try catch loop. So we say try, hey, Python, try to do this. Try to add hello to the number 5. And except, which means if there's a problem, right? If there's an exception, except print error. And it's just going to print out, hey, there was an error. And if we run this code, it prints out there's an error because there's an error, but notice how the rest of our code runs, right? Because if we go back to a previous, so I'm just going to comment this out real quick, and we're going to demonstrate something over here. If I go take our line 2 again, and if we have line 2, oops. We have line 2 just as it is by itself, and after that I say hello, or after that I say print hello, and we run the code. What's going to happen? We never actually print out hello, right? Because we just get the error and the program stops immediately. But if we delete that line and we uncomment all of these lines and we run it again, it tells us there's an error, but it keeps going. It does the rest of the program. It runs everything else we want it to do, which is perfect, right? It's, okay, there's an error, great. You'll get the notification there's an error, but everything else doesn't crash, and we can deal with that error. We can deal with that error and figure out how to fix it, but we don't have to worry about it. Except that this isn't really very meaningful, and I know the kind of error to expect. So if you notice over here, it says too broad an exception. Why? Because really, when I say except, we can say something very specific. We can just say general exception, and that's going to be any kind of error that exists. And then we just go exception, exception E. No, and then we just do exception dot. Nope. Okay, sorry. If we can catch any error, and that's great, but that's way too broad. We want to catch the type error because we know the kind of error that it is, right? It's a type error. So, and then we can print out wrong type. And then we do, and now if we run this code, we get wrong type. That's fine because we caught that error, and that's great. But now what happens if we change this to something else? If instead of doing the wrong type, we say, let's say print A. Now, of course, there's a big error here. What's the big error here? I never defined A, right? A is not a value that exists. A is not a variable that has a definition, so that's going to cause an error. So if I run this, I get back the error, and notice how it's still crashed. Why? Because it's a different kind of error. It's not a type error, it's a name error. So if I put the name error over here, and we run this code again, now it's wrong type is the message because I set that message. So I can get a general exception that's just catch everything, or we can get a very specific exception, which is, the specific thing that I would want to do. So in the case of the name error, it's going to be a name. In the case of an exception, it's going to be an accept, and so on and so forth. And we can do a bunch of other things with this error. We can tell us exactly what we can see what the error is, and we can catch the error, and we can still run the program. The other thing we can do is we can write our own error, so we can use the built-in error. So I'm not going to cover how to write our own errors today. We're going to show you how to use some built-in errors. So we're going to define a function called fact, right? This is that factorial function that we wrote the other day, and it's going to take in n, right? N, num. And it's going to just return, and I'm just going to actually pull up that function, and right here's the factorial function. This has a great little, and we're just going to store the factorial function. Now we got a problem, right? Because this factorial function only works if a number is actually a number. So we are going to say if type number is not type of 90, right, which is int, then we're going to raise type error, and we're going to include a message, right? 1 second here, let me just double check. Yep, raise type error, and we include the message, and we say expected. Oops. What's this is? What's the problem with is? Oh, sorry, we should not be using is here. We should be using not. We should say not equal. Not equal. There we go. Not equal. And it's going to say, hey, don't use that kind of not equal. Yeah. Sorry. This is just Python being reformat this file, flip. Okay. And it's gonna. Sometimes you just gotta ignore it and move on. So in this case, expected a number got and then we're just going to go over here, and we're going to use the f string, and we're going to cheat a little bit, and we're just going to say type of number. So what does this function do? It checks that the type is a number, expect if not is instance name Oh, sorry. I am... Okay. That's the right way to write this. So what this just checks is, hey, is this number this data type? So in this case, is number an int? If it is, if it's not an int, then we're going to raise this error. And if it is this int, if it is an int, then we're going to run the function. And so now I'm just going to print, so I'm going to just run fact 5, and we're going to test this. First we just test our function to make sure it works properly, and we run that, and it works beautifully, right? It just doesn't show me any errors. And if I print out my results, I should get 120, and I run it, and I do get 120. That's magnificent. Now we're gonna make an error here. We're gonna make it 5 a string, and now we run this, and we should get an error. Yep, expected a number, got a class string. So we expected a number and we got a string. That's a problem. And notice here that what's actually happening is I got to write we wrote our own error, and we raised the error, and that error actually caused it to crash. So if I didn't want my program to catch, I would say try this horrible thing that I know is not going to work, and I'm going to say accept a type error, and then we can print wrong. Whoops. We can print wrong type, and then else, or not else, and then we can accept the general accept, and we can print unforeseen error, and just that. And I'm going to run this, and hey, we get a wrong type, right? But if instead of type error, I just change the type to, let's say, a name error, and we run this all thing again, unforeseen error. So I'm going to change it back to a type error. Now, the important thing here is this try except loop, as well as the raise. What exactly the condition is that makes it raise this is instance is basically takes an object and a type, and it says, hey, is this object part of that instance of that type or not? Which is cool and useful, but it's not as important as understanding this try except thing and understanding this raise thing. Type error is a built-in error type. It's an actual object. It's an actual class type, and it's one of many different kinds of exceptions and errors. And you can look through the full list. You can Google that, or you can just accept them as they come, and kind of, if you predict a specific thing to happen, then you can always see the error message and based off of that treat your results. But now you understand a little bit more about how to avoid errors popping up randomly. Sometimes you want to try except. You don't usually, unless it's there's a very specific behavior might happen. For example, if you're expecting user input and the user gives you the wrong kind of input, then you're going to want to be able to accept those errors and deal with them. And that is what you would do with this try except, and that's what you do with try except, right? You'd say, oh yeah, the user gave me the wrong type. That's cool. I just want to tell the user, hey, you're giving me the wrong type, so I'll give them a meaningful. I just want to tell the user it's the wrong type without crashing the rest of my program, because the rest of my program is unrelated to running this. And as always, if you have any further questions, I am here to answer them.